Hello, let's continue our Sudoku adventure with Multiples of 6 by James Kopp. So we have normal 6 by 6 Sudoku rules. That means in each row, each column, and each 2 by 3 box, we are placing the digits 1 to 6 exactly once each. We also have these arrows in the grid attached to a circle. The way these work is whatever digits go on the arrow, you sum them up, that goes in the circle. So if this was 2, 3, 2, 2 plus 3 plus 2 is 7. That's no good. 2, 3, 1. 2 plus 3 plus 1 is 6. We could put a 6 here. 7 didn't work because you can't. There's no 7 in the puzzle. Okay. In addition to that, there's all these diagonal arrows outside the grid. These arrows point at some set of digits along the diagonal, and the sum of those digits is divisible by 6. It's a multiple of 6. So mod 6 is 0, if you prefer. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I think we have a gimme 6 right here. The only multiple of 6 you can place on one cell is 6. And then these add to, well, they can't add to 12. So these are going to add to 6. They're going to be 1, 5, or 2, 4. All right. I think the key thing is to look at this arrow, though. So we know that the sum of the arrow plus the circle is a multiple of 6. And the other thing I know is that whatever the individual sum is, if we sum this plus this, it's twice that, right? So whatever this is, this sum is twice it. Whatever this adds to, the sum is twice it. So that gives us the fact that it's even for free, but it also needs to be divisible by 3 in addition to that. So that means that our sum is divisible by 3. It's either 3, 6, 9, 12... Well, it's 3 or 6 is the key there, because the individual sum cannot exceed 6, or the total sum can't exceed 12 if you prefer. So this is 2 or 3. Wait, what am I talking about? It's 3 or 6. What did I just do? And so 3 would require 1, 1, 1. So that's an option. The 6 could be 2, 2, 2 or 1, 2, 3. I think those are the options. But either way, these are from only 1, 2, 3. We can't exceed 3. If we tried to put a 4 in any of these, our minimum would be 4 plus 1 plus 1, which is 5. Wait. No, 4, 1, 1 would work too, wouldn't it? That would add to 6. I mean, shoot. If we included a 5, that would be bad. 5, 5, 1, 1 is already 7. Yeah. So we didn't actually learn a whole lot. We just know it adds to 3 or 6, I guess. Maybe this 6 is key. One of these is 6. We can't put a 6 on an arrow like this. Put a 6 here. What's this going to be so that this doesn't exceed 6? There's no 0. So that's not a 6. So 6 is one of these two. And that's interesting because this little arrow here is telling us that whatever this digit is also here. So our options are this is a 6, making that a 6, meaning that can't be 6, or the only alternative is this is a 6, making that not a 6. So that gives us the 3, 1, 1, 1. Perfect. Because if this was a 6, there'd be nowhere to put 6 in this row through the medium of this arrow and this column. All right. Nice. Now we have some more diagonals. Oh, this is a gimme 6. Sorry. So I didn't need to do all that logic because I missed the gimme 6 up here. That's a 6 and that's a 6. So this can't have 1, so this has to be a 2, 4 pair. And this is a 3, 5 pair. Okay. Now, this is 3 plus 5. That's 8. We need to get to a multiple of 6. So it's going to have to be 12. So this is a 4. That's 2 and 4 here. What's this pair here? A 2 and a 5. So I'm thinking about this diagonal. It's the only diagonal we haven't done. Oh, this is a 1, 5 pair. What's that leave here? 3, 4, 2, 3, 4? That's not a 4. So this can't be 6 because there's a 6 in the row. So we can't use the 4 because we'd be 4 plus 2 is 6 minimum. So we're going to be a 2, 3 pair adding to 5. That's 2 and 5. That's 3 and 5. That's a 3 and a 2. That's 4. This can't be 4. That can't be 2. All right. So this diagonal is what's left. Maybe I should pencil some more. This is a 2, 5 pair, and this is 3, 4, 6. It's not a 6. 6 one of these two. So what can we learn from this being divisible by 6? This is already 7. So we're mod 1 right now. We need to get 5 more, mod 5 more. These could add to 6, a 2, 4. Yeah, I'm not sure if we can do this yet. Maybe there's more Sudoku. This is a 1, 4 pair. This is 2, 3, 6. That's not a 6. We need a 3. We need a 2. I'm not sure. Is there more to do here? That one, that one, that one. That one. I think it comes down to this. Okay, so if this was a 1, we would be mod 2. So this would have to add to mod 4. So how could this add to mod 4? Either 4 or 8. Well, we're not adding to 4, but we could add to 8. We could do 2, 6 here. So if this was a 1, this could be 2, 6. If this was a 5, then now we're mod 0. So these two would need to add to 6. And the only way we're doing that is 2, 4. So this is a 4 or a 6, and this is always a 2. That's 5. That's not 5, so that's not 1. That's not 2, so that's not 4. So we get the 1 and the, oopsie, whoa. We get the 1 to 5 here, 4 and 1. 3, 2, 5 and 1 here. Let's clean this up. Oh, this ended up 5, so we need this to be 4 to add to 6. That's 6, 3, 6. And then down here, this one is a 2, and then up here we need a 3 and a 4. That's 3, that's 4, and we're done. All right, cool puzzle, James. Nice modular arithmetic there at the end. Yeah, just basing it off this being 1 or 5 helped. That's crazy that this had to be 2. There might have been a more holistic way to look at that, but case checking worked quite well. All right. Well, how'd you do?